Electric fields, question 4. Two charges are positioned as shown. Calculate the electric field strength halfway between the two charges. Well, this is very similar to question 3, but now we have a negative charge here and a positive charge here. So at the midpoint, the electric field due to this charge would be to the left, as it would tend to attract a positive charge. At the midpoint, the electric field due to this charge would also be to the left, as this would tend to repel a positive charge. So now we need to add the electric fields from both, which we can do with this expression. Putting in the values, they are both going to be 25 millimeters from the midpoint, and so this gives an electric field strength of 7.2 times 10 to the 8 newtons per coulomb. Electric field is a vector, and so we must specify the direction, and in this case the direction of the field is to the left. Explain why there is a point to the left of Q1 where the electric field is 0. Well, to the left of Q1 the field due to Q1 will be to the right, and the field due to Q2 will be to the left. Where both fields have the same magnitude, they will produce a 0 field. Now we're asked to find the position of this 0 field point. Well, again we can use this expression, and this part is made entirely of constants, so cannot be 0. Therefore this part must be 0, which I've written here. Now we can put in the values. Q1 is minus 10. I've missed off the microcoulombs, and I've missed off the units here as well, just for clarity. And we'll call the distance to this side of Q1 x. Q2 is plus 40, and that will be x plus 50, and this equals 0. We can rearrange to get this, then expanding out these brackets gives this expression, which we can now simplify to this. Simplifying again, we get this, and dividing throughout by 10 gives this expression. We can now solve this to get 3x plus 50 times x minus 50 equals 0. 3x plus 50 is going to give a negative term, putting the position here somewhere, which isn't possible. So what we want is x minus 50 equals 0, so x equals 50 millimeters. So the 0 field will be 50 millimeters to the left of Q1.